Yes, hello students. So we continue with rules for nomenclature. In the previous video, I told you how to choose longest chain of carbon atoms present in the molecule for nomenclature purpose. Now, in this video, I'll tell you more rules. Now, the second rule is the direction of counting carbon atoms of the longest chain. What does it mean? Look here. You know this simple compound? It has a longest chain of 4 carbon atoms. We always call it 2-butanol. We do not call it 3-butanol. It means we count carbon atoms of this longest chain in this direction. We do not count in this direction. So according to the first rule, we choose longest continuous chain of carbon atoms in the molecule. In this second rule, we'll study in which direction should we count carbon atoms of the longest chain. For this, there'll be two parts of second rule. First part is if there is no functional group and any number of substituents are present. There's no functional group and any number of substituents are present. See, if this is the case, then we should count carbon atoms of longest chain in that direction in which first locant is the lower number. First locant should be lower number. For example, you can see first of all there's no functional group. Both are substituents, halogen and nitro. In this direction, they are present at 2 and 4. In this direction, they are present at 1 and 3. You have to look at the first locant. First locant is lower number. This one is correct, not this. Right? I'll take more examples. In case first locant is same in both the directions, then we'll look at the second locant in the molecule. For example, this is a chain of 5 carbon atoms. These are 2 methyl groups. And let us say this is chlorine. You know, this is the longest chain. If I count carbon atoms of the longest chain in this direction, positions are, this is at 2, this is at 2, and this is at 4. In this direction, this is at 2, this is at 4, and this is at 4. First locant is same, that is 2. Then we consider second locant. Second locant is a lower number in the first case, higher locant in the second case, higher number. So we'll count in this direction. But if there are, say, 2 locants and position is same in both the directions, then in which direction should we count? Remember, in that case, we'll count in that direction in which lower position is given to that locant which is attached to a substituent which comes first in alphabetical order. Which comes first in alphabetical order. Look here. For example, these are 2 locants. You count in any direction, their positions are 3 and 4, 3 and 4. Now, in which direction should we count? Then you have to consider names of these substituents. This is bromo, B, and this chloro, C. Alphabetically, bromo comes first. Therefore, bromo should be given lower position. That is, I'll count in this direction, not in this direction. One more example. Let us say Again, 3 and 4, 3 and 4. This side chain is ethyl, starts with E. This is methyl. Ethyl, E comes first. Therefore, this will be the direction of counting. So that was the case when there is no functional group present and any number of substituents are present. Now, second part of this rule says that if there is one or more functional group, and any number of substituents are present, any number of substituents. In such cases, we should count in that direction in which functional group of maximum preference is given lowest position. After that, we'll count in that direction in which the very first locant is the lowest possible number. For example, this I gave you the example. This is called 2-butanol because position of the functional group should be low, right? After that, let us say there is chlorine here. Since position of the functional group should be low, direction in any case will remain the same. I'll take one more example. This is a chain of 7 carbon atoms and OH group at 4th carbon atom. Let us say there are 2 more substituents present. One is functional group NH2, the other is chlorine. Chlorine is a substituent, NH2 is a functional group, along with OH is also a functional group. Now, in this molecule, OH group has a maximum preference. But the problem is, you count in any direction, position of OH group remains the same. So, which direction should I count in? Now, I'll look at these locants. Position of the first locant should be lower. See, in this direction, it will be 2, 4, and 7. In the opposite direction, it is 1, 4, and 6. In the circle is the position of functional group of maximum preference that remains the same. Now we have to see which locant, in which case first locant is the lower number. This is the lower number, this is higher number, so this will not be taken. This is the right choice to count. Now, if this type of functional groups or substituents are present on the ring of a cyclic compound, maybe saturated or unsaturated or aromatic ring, then again the functional group of maximum preference should be given lowest position. Then counting may be clock or anti-clock direction. That clock or anti-clock direction will again be decided on the basis of first locant should be a lower number. Now, I'll give the example. Group of maximum preferences CHO. It means this part of the molecule in the circle is benzaldehyde, right? Now, this is position 1. From this carbon, if I go in clock direction, this will be at a lower position. Locant is 2. But if I go in the anti-clock direction, then the lowest locant will be 3. Well, mentioned like this. In clock direction, locants will be at 2, 4, and 5. In anti-clock direction, locants will be at 3, 4, 5 and 6. This is the lower number, will count in clock direction. One more example. Let us take one more. This is a saturated ring. Group of maximum preferences OH. This part in the circle is cyclohexanol, right? Now, if I count in clock direction, locants will be at 2, 4, and 5. If I count in anti-clock direction, locants are at carbon number 3, 4, and 6. This is the lower number I'll count in clock direction. So that's how we decide in which direction should we count carbon atoms of the longer chain or carbon atoms of the ring. Then third rule is about suffixes and prefixes. This list you'll find in the book also, but I'll revise for you. See, you might have noticed that sometimes for OH group, we use all, ethanol, propanol. Sometimes for OH group, we use hydroxy. Remember, all is suffix, hydroxy is prefix. In the entire molecule, for which substituent or functional group we use a suffix or prefix? It's very simple to decide. Remember that functional group in the molecule which has maximum preference. For that, we'll use suffix. For all leftover functional groups or substituents, we'll use prefixes. Now, what are these suffixes and prefixes? I'll read out for you, although there's no point wasting time to note down. Like COH group, oic acid is the suffix. You know, they're called alkanoic acid, ethanoic acid. So for COH group, suffix is oic acid, prefix is carboxy. So first I'll speak suffix, then prefix. Then SO3H group, it is sulfonic acid and prefix is sulfo. For ester, COOR, suffix is O8, OATE, and prefix is alkoxycarbonyl. Alkoxycarbonyl or alkoxyformyl also is used. For acyl halides, COCl, suffix is OYL. OYL. Oil halide, they are called alkanoyl halides, and prefix is halocarbonyl, chlorocarbonyl, bromocarbonyl, like this. For CONH2, amide group, suffix is amide, prefix is carbamoyl, CARBAMOYL. Then for CHO group will be taken up in detail later in these rules. This is a typical one. For CHO group, suffix is not an issue. Suffix is ul, ethanol, propanol, butanol. Ul is the suffix. But there is a catch in prefix. See, if CHO is a substituent, then we use the prefix formyl for CHO. I'll take up examples later in rules, but if CHO group is a part of the longer chain, it is a secondary substituent, but it's a part of the longer chain, then we use the prefix oxo if it is a part of the chain. Right? Don't worry, we'll take up in rules later. For ketonic group, it is one is suffix, and prefix is oxo. For CN, cyanide group, it is nitrile and cyano. For OH, all and hydroxy. For NH2 group, it is amine and amino, very much similar, amine, amine, and prefix is amino, amino. Now there are two typical groups now. Look here. Carbon-carbon double bond, carbon-carbon triple bond. Suffixes, very simple, "-ine" and "-ine". Prefixes. Prefixes are also same, but they are used in the form of infixes. Now, what is infix? I'll give an example. It will be clear. There's a very simple compound, 2-butene. 2-butene. Suffix is "-ine". At the end, we are using "-ine". If there is OH group also present in the molecule, then group of maximum preferences OH. For the double bond, I'll use prefix, right? Now, IUPAC of this compound will be but 2-ene-1-ol. But 2-ene-1-ol. It means "-ene" is not coming at the end. "-ene" is fixed in between the IUPAC name. It's in the middle of the IUPAC name. That is called infix. Similarly, if triple bond is a secondary group, not the group of maximum preference, then prefix will be used in the same manner, so and so, "-ine", then major functional group. After that, we are left with those substituents which do not have any preference order. Those 5 substituents which I told you in the beginning, they do not have any suffix. For them, only prefixes are used. Like for halogen, we use halo, chloro, bromo, iodo, fluoro. For OR, alkoxy group, we use alkoxy, suffix, right? Oh, sorry, prefix, not suffix. Methoxy, ethoxy, like this. For NO2, nitro. For any alkyl chain, we use alkyl, that is methyl, ethyl, propyl. And for C6H5, prefix used is phenyl, right? We'll take up more rules in next video.